Hello friends, today we're going to be tackling VSTACK-Man, Coby Dombrowski's take on Pac-Man in Excel. This is from the Last Chance Qualifiers in Vegas just a few weeks ago. And let's see if we can do it without any macros, without any lambdas. It'll be a challenge. Ready, set, go. The first thing I want to do is set up my named ranges and tables and whatnot. Whoops. Let's get some of this. Let's call this map. And I'm going to make a vertical column of addresses. So we'll say to-call address. I want the row of the map and the column of the map. So those are addresses. To get the values, we'll just do to-call. And we'll call this address and value. Copy paste values and turn it into a table with Control-T. So now there's a bunch of different values on the map. Some of them are boundaries, and I want to know which ones are which. So I'll take the unique characters of the values, and let's go ahead and sort that. These ones right here, from here to here, are my boundaries. So I'm going to call that walls. This little dot is what VSTACK-Man eats. We'll call them code because that's what the case calls them. And then the floppy disk icon is our power up. So let's call that power. Now with the setup kind of done, let's do our bonuses. How many wall segments are in the maze? So that's going to be some. We're going to count if within the map, looking for each of our walls. One code block in the maze has slightly different font color than the rest. What cell is it in? Now, I was not able to solve this on the day of. I ran out of time, but here's how you should do it. So we're going to search by format. We're going to select a format from one of these codes. In the search, we're going to look for all, and I'm going to select the map, and then find all, and then I'm going to press Control-A to select all of the code icons that have that same style format. And I noticed that this one right here is not selected. That is the one that must have a slightly different shade of color. That's in cell AE35. So that's our answer. AE35. Okay, now the rest of the bonuses are for, we have to solve the rest of the levels before we can do those. Level 1 is just a lookup. X lookup the address in our table and return our value. Okay, level 2, we are traveling across these different addresses and we want to count how many code blocks we can eat. So it's going to be sum X lookup and address and value, and then equals code. We want a yes or no. We're going to sum up. We're going to have to use a double negative to turn this into an integer from true false. There we go. Okay, on this one, same thing, only you cannot eat the same code pellet twice. So we have to track which ones we've visited already. Okay, so I'm going to say map the sequence here, lambda s. And so what I'll do is say take, I want to say take this array. How many columns? I want that S, whatever our sequence is at. We're taking that many, all of the columns up to each point that we're at. And then we're saying index of that same array. And how many of those equal each other? So we will sum the double negative. Okay, so that's our sum. And now let's turn it into a boolean. So if our sum is positive, that means that one has been visited before. So if it's greater than 1, sorry. If it's greater than 1, then it's been visited. And let's turn that into a 1 or a 0. So there we go. Here's our array of have we visited this before. So now we just multiply this array times X lookup. We're going to look up each of these addresses just like before. And so if that equals code, then we're going to get 1. Now these are all going to be 0, so let's actually wrap this in equals 0. So that should be our sum. Sum these up, and we'll just take that formula and move it over here. Probably got an anchor wrong. Got to anchor this one right there. Oops. There we go. Okay, so in this one, they're giving us an address and a direction, and we're meant to see if we travel that direction, how many pellets can we eat, how many code blocks can we eat before running into a wall. And I've done this with a formula before, and it actually takes me longer to do it with the formula than it does to just manually do this. So sometimes manual is the best way, and that's the way I'm going to do it today. If I was able to do lambdas, I would be able to solve this much faster. But in the manual way, the old-fashioned way, I think manual is the way to go. And that doesn't surprise me given the case author. Coby is known as being one of the more, I don't know, more willing to use manual solutions. And so the fact that some of that is applies to his cases is not surprising. So we want to go left from here, 14, or 20, 0. Alright, and 12. Oops. Copy. Which direction? This is going down. 6. And this is going to the right. I find myself accidentally doing Control F instead of Control G by muscle memory. This one's going down. 21. Alright, V11 going up. 2. Going up. 2. Going right. 12. This one goes up 5. This one goes right 7. Left for this one 21. Left for this one. How many is that? 13. Down 22. Right. That's 11. Up. 21. And left. Alright. 12. So, let's cross our fingers that we did this right. I should have probably checked a couple of them before, but we're okay here. Alright, so that's the end of our manual solutions, I promise. Going to level 5. Now what are we doing? This time we're collecting pellets, but a bug is there to eat us if we end up in the same cell. So let's start off with this logic. This logic here is just, here we're going to go all the way from to DB, column DB. Now before we had AJ in it. Let's just replace AJ to DB. And we don't need format anymore. Clear that. Replace all. Okay. So did I do something wrong here? Oh yeah, I probably have to change this as well. My sequence. Okay. So interestingly, look, all I did was copy the logic from up here where we were just collecting all the code pellets. So that will be the answer if the bug never shows up, which actually gets you like half the points for this level. But now we have to model when will the bug intersect with you as you're traveling a map. So we will say X match true where this array equals this array. And then if it's an error, so if error, it means the bug never hits, and we'll just give 100 because you'll allow all 100 turns. So copy and paste that. I see a handful of times where the bug does eat us. And so here on our sum, we'll still keep this whole base formula, but just take the number of columns until the bug gets to us. And copy and paste that. There we go. Alright, level 6 is a tricky one. This one, we're actually going through the maze looking for the closest power-up. And so we're going to need to do a distance map. Without our lambdas, what we'll do is make a copy of this tab. We'll call it level 6, L6. And clear this stuff out of the way. And let me just also get rid of that, any of the references that copied over from here. So names with errors, I'll delete these. Clear filter. I think I also want to get rid of map. Anything scoped to this worksheet, though. I don't want that. Okay. So with that, I'm going to make a few copies. I just need F to AG. I'm going to make a few copies of the map. So this is going to be my address map. This one's going to be my walkable map. It'll tell me yes or no if it's walkable. And then the last one is going to be my distance map. So we don't need any of this anymore. Okay, so let's populate this. Starting here on this cell, we will say equals address, row of this, column of this, and 4. So we're getting all our addresses, and I think let's get one more. Okay, so there's our addresses. I can copy and paste values. I don't need the formula anymore. Over here, we're going to put whether it's walkable or not. So it's walkable if two things. If it's not a border, it's walkable, and if the bug is not present. So on the case, it gives you 3 bugs and where their location is. So here, we're going to have to bring these in. Let's copy the game numbers in and start our data table setup. So we're going to do a data table out here. Let's give us some room. And then here, let's do a next lookup of that case B, looking up case. Not sure which columns we need. Let's start with G. We need G to J. G to J. Okay, so G, J. So there, right here, these ones are our bugs. In fact, let's just, to make this easily understood, let's copy this. So our bugs are here. So as we're doing this, we want to say, okay, so if, let's say actually, is number X match. Let's change this to is name. So if it's walkable, then we'll get an error when we look for this character in walls. If it's a wall, it'll be a number. For false. Okay, good. So that means, hold on, yeah, let's say is, this is not walkable. False is the answer we want. Okay. And then we'll also say is NA this address, oh sorry, X match this address in these bug cells. Okay, so that's 0. If we copy and paste this down, we should get, let's see, something not quite right here. We expect Oh, that's okay. It's showing up as 1 because this is empty, but it won't really impact our map, our ability to solve this. Okay, this looks okay actually. So now we need the distance map, and the distance is going to depend on your start. So that's the beginning of our distance map. We'll say if our address over here equals our start address, then 0. Okay, and if not, then let's check if it's walkable. So if this, if that equals 0, it's not walkable. Let's put 999. Otherwise, we're going to do the minimum of what's around me right now. So left, up, right, and down, plus 1. And I realize that I need a guard. I like to put a guard of a large number around the borders here. Right, not there, right here. And that way, when I search for the minimum, I won't get any bad values. Okay, so the guard is set up, and I should be able to copy and paste this formula. Okay, something's wrong because I don't expect to be able to travel into the middle here. So we're seeing our 0 populate from here, and for some reason it's letting us through here. It shouldn't. It's not walkable. So why is this allowing us through? If that is 0, then give us 999. How on earth? Maybe it's not coming right there. Let's make all these a bit bigger for a moment. You can see where these are coming from. All these values. Wonder if there's no other merging. Is that what's going on? Home, unmerge. Oh, is there a weird anchoring? I think I have an anchoring problem here somewhere. Which one would do that? I don't think I need to anchor any of those. Alright. So we seem to be off by 1. That's probably what the problem is. One of these is wrong. Yeah, this guy's off. Okay. There we go. That's what we expect. Okay. Now we've got that distance map set up. And what I want to do is filter the distances. So 2call. I have to make a 2call. Filter that on 2call map equals what we're looking for the power-ups. We want to find the closest one. So those are the distances to the different power-ups, and the answer will just be the minimum. And I'll turn this into a data table. And there we go. So we're missing 2 answers, and I think I know why. I think when you get to these spots on the map, it can actually wrap around to the other side. So right here, yeah, right here, we need to be able to wrap over here. So I'm going to click into that. I'm going to move this reference over here and do the same thing over here. Click this, move that reference over here, and then do the same thing on the left hand side. Move this left reference to the right of the map, and take this one and do that one. This will be the last one. Okay, with that, these should be the right answers I'm expecting. And there we go. Okay, level 7 Level 7 we have 3 bugs, and the power-ups come into play. So now you can eat a power-up and be invincible for 30 turns. So I think we're still going to do a data table solution. And so we'll set those up over to the right. If he sells over, we'll say equals x lookup this in B. I know that we're going from G all the way to now GX. So there's our inputs. That's our address. So the value of those things is going to be x lookup here, m address, and the value. Those are the values. Okay. I want to see, have we visited each of these values before? You can only pick up the things once. So visited. Oops, not formula. So I'll say map the sequence. Actually, let's bring a sequence over here. 200 moves. Not there. Sorry. Copy. Right there. Sequence. Alright, so I will map the sequence. Lambda S. And just like before, same logic as we did in earlier level. We're going to say take this whole array, just the number of columns that are equal to the sequence number. See if it equals the index of that sequence number. Okay, and then how many are there? Some. That gives you how many. And so if that number is greater than 1, if it's greater than 1, it's visited. So this would equal it's previously visited. So we're going to say equals, if it equals 1, it hasn't been visited before. Okay? Now let's turn this into an integer. Not visited. Okay. So here we go. Let's then see if we have a power-up. Are we grabbing a power-up on any given turn? And that will be this equals power times this equals 1. And so you'll see, yes, we grab this power-up here. If we were to hit AF34 again, we don't grab it a second time. Okay, now we need to see how many times we're invincible, or how many, you're invincible for 30 moves. So I will take, what are we going to do? Take, we would take the power up and for each one, it's going to be our sequence. And then of those, we will take the last 30. We'll see if any of these intermediate values equal 1. Actually, just sum it up. Sum. And then say is greater than 0. No. Each one has to sum. I don't need to map, do I? Oh, I know. This shouldn't be dynamic if I want to do it that way. So I want to say take this array, power up, this many columns. Okay, and then take -30 of that. Let's enter this one. Yeah, okay. So now we'll say sum is greater than 0. Okay. Now we should be good. So once we hit the power up right here, we should be invincible for 30 turns. Yeah. Okay. So if we're invincible, then it impacts the bug. So the bugs have their addresses. They move. So here are the bugs, starting at G315. G315. So I'll come down here, and I'll say equals if on previous value, if they're already dead, then they stay dead. Otherwise, if G315 equals the address we're at, and we're invincible. So if we are invincible, then that's dead also. Otherwise, G315 is the location. Okay, now which of these do I need to anchor? I need to anchor this to the row and anchor this to the row. So like that. Okay, so you can see one of these bugs got eaten while we were invincible. Right here. We were at AF23, we were invincible, the bug steps into AF23, and now they're dead. Good. Okay, so for any given line, did we run into a bug? And a live bug, I should say, when we're not invincible. So we'll say is number X match our address against the bug addresses. Okay. And then we'll say we're dead at, so the first time we hit a bug equals X match true. Well, not true, 1. 57, and then just in case that there's no bugs, compare 200. So now we want how many codes did we eat? It's going to be equals sum take, and then we'll say this equals codes. Okay, let's make that an integer. We're taking just the number of columns until we're dead. Summing. Did something wrong here. Shouldn't close that, take that too, right? Okay. And so that's our answer, 46 codes equals that. Okay, and then no. Did something wrong. Did we check if they're visited? I think we have to check if the codes are visited. So this actually times this as well. I don't know. There we go. Alright. The bugs have names. So from 68 to 76, right here, we're going to say equals concat char, and we're going to add 64 to these answers. It's 64. To get bubblegum is the name. Alright, across all games in level 5, excluding the example, what is the sum of all move numbers where VSTACK-Man was caught by a bug? So level 5, caught by a bug. Is this the right level? Yeah. That would just be the X match. It'd be these answers but 0 instead of 100. So 273. 273. Really close, but not close enough. Level 7. 3. I'm gonna have to expand this. So I'll say equals countif x equals 3. Yeah. Looking for the true at game 135. 135. 17 seconds late. Fuck. You win some, you lose some. But that was all without lambdas. Probably could have done a lot better, a lot faster if we had our lambda kit. Thanks for watching. I'm Excel Gladiator, and my goal in creating this video is to help people level up their Excel skills, as well as grow the world of Excel esports. If you want to help me do that, please like and subscribe, drop a comment, or check out one of these other videos.